Okay, so the final lesson in this unit is on something called the properties of systems of linear equations. Okay, so um, we're basically going to be looking at the different possibilities for the number of solutions. All right, so a linear system can have 0, 1, or 2 solutions. Another thing that this has been called in the past is called nature of the roots. Right, so if you see that terminology, that's basically nature of the roots is just asking how many solutions is there to a system. All right, so far for the most part, and we're just going to explain this graphically. So far, we've been dealing mostly with systems with one solution, right, where the two lines would intersect at a certain point, and that point there is your solution. However, it is actually possible to have a system with no solution. And that occurs when you have parallel lines, right? If you have two lines that never cross because they're parallel, then the system will have no solution. And the other one here is infinite solutions, all right? So even though it looks like there's one line drawn here, if you have two of the exact same lines that overlap, then they would overlap infinitely many times. That's the infinite solutions, all right? So it'll be a little bit clearer in terms of like types of questions that you'll be asked, all right, when it comes to the number of solutions, all right? But first thing I want to point out here is in order to get one solution, you have to have different slopes. Remember, the slope of a line tells you the direction and the steepness. So if you have two different slopes, then obviously the lines have to intersect somewhere. But then in that case, you'll have one solution. When you have no solution, it's when you're dealing with parallel lines, you're going to have the same slope, but different y-intercepts. All right, so if you have two lines with the same slope, they'll never cross, right? But they have to be apart from each other, so they have to have two different y-intercepts. Now, the third possibility, which is infinitely many solutions, actually, you know what? I just realized is that the first line there is incorrect, right? You can have no solution, you can have one solution, or type this in, infinite. So means that I got to. There we go. Okay, so that was an error. All right, so you can't have two solutions. You cannot. You can have infinitely many. All right, so that occurs when you have basically two of the same lines. So if you have the same slope, and the same y-intercept. And I'm going to show you through an example how to create, this situation here where you have, two different equations, but they'll have the same slope and same y-intercept. All right, cool. So first example here, we're going to determine the number of solutions of this linear system here. Okay, so what you notice right now, they're in kind of like general term. So what I want to do is I want to find, go back to this picture here, I want to figure out what the slope of each line is, as well as the y-intercept. So in other words, I want to convert these into slope-intercept form. So to do that, for the first one here, 2x, we want to basically isolate the y, right? So I'm going to take the 2x, move it over to the other side. So this, we got room over here. I'll label that 1 and 2. All right, so I'm going to take the 2x plus 5y equals 20. Okay, so I'm going to take the 2x, move it over to the other side. So I got 5y equals negative 2x plus 20. And then to isolate the y, I got to divide through by 5. So therefore, we get y equals, okay, so the slope here is negative 2 over 5x, and 20 divided by 5 is 4. Okay, so the first line, it has a slope of negative 2 over 5 with a y-intercept of 4. Now, if I do the same with the second one here, let's go negative 4x minus 10y equals 60. All right, so again, this time I'm going to change the slope-intercept form. So I'm going to move the negative 4x to the other side. So I get negative 10y equals positive 4x plus 60. And then I'm going to divide through by negative 10. And as a result, we get y. So as a result, we get y equals, now 4 over negative 10, that reduces actually to negative 2 over 5. Okay, so I can reduce that to negative 2 over 5, x, and 60 divided by negative 10 is negative 6. All right, so if we compare these two lines, you'll see that they have the same slope. All right, so they both have a slope of negative 2 over 5. Just circle that in red. All right, so what you notice here is that the slopes, same slope. However, our y-intercepts are different. All right, so what does that mean? Well, we have two lines with the same slope but different y-intercepts. So that means that these are parallel lines, which means that they'll never intersect. All right, so as a result, we can conclude that this system here has no solution. Actually, I probably should have wrote parallel lines. All right, so if the two lines are parallel, you're going to have no solution. All right, so again, we had to change these to slope-intercept form to see the slope and the y-intercept. All right, cool. So let's take a look at this one. All right, so again, I have two equations. I want to change each one to a slope-intercept form. So the first one here, if I take the 2x plus 5y equals 20, now when I isolate the y, I'm going to move the 2x over to the other side. 5y equals negative 2x plus 20, and then divide through by 5. Y is going to equal negative 2 over 5x plus 4. Okay, so that's converted to slope-intercept form. Now the second one, if I change that to slope-intercept form, so I'm going to take the negative 4x minus 10y equals negative 40. All right, so this time we take the negative 4x, move it over to the other side. We get negative 10y equals positive 4x minus 40. Divide through by negative 10. So this is going to be y equals. This reduces to negative 2 over 5x. And now negative 40 divided by negative 10 is positive 4. All right, now if you compare these two equations that are in slope-intercept form, you notice that it's exactly the same, right? I got negative 2 over 5, negative 2 over 5. I also got plus 4 as my y-intercept. And I also want plus 4 on this one. So these are essentially the same line when you graph it. Right, so same slope, same y-intercept. So as a result, this system here is going to have infinitely many solutions. Right, so the reason it's infinitely many solutions is because these two lines overlap each other. All right, so this system, like if you graph this line and you graph this line, you get the exact same line. The two lines would all overlap. They cross everywhere. That's why it's infinite. Cool. All right, so in the next example, we're going to do something a little bit different with these concepts. Is we're given an equation of one of them, we want to write another equation that will form a linear system with, again, exactly one solution. All right, so you can just go negative 2x plus 3y equals 18. So this is the equation that's given, and we want to create a second one here where the system would have exactly one solution. All right. So in order for this to be true, we just need to have different slopes. So if the two lines have different slopes, then if the two lines have different slopes, then they'll cross at one point. All right. So best way to explain this here. So remember, slope is rise over run. Okay. So if I was to change this first one into slope-intercept form, right, I would take the negative 2x, move it over to the other side, and I'd have 3y equals positive 2x plus 18. And then I would divide through by 3. So there. And therefore, y is going to equal 2 over 3x plus 6. Okay, so the slope of this line, this first line, the line that's given to you, is 2 over 3. Well, if you kind of look at these, the coefficients here, right, 3 and the negative 2, you can see that, yeah, it's rise over run. Okay, so algebraically, you move the negative 2x over the other side and divide by 3. So essentially, you take this number here and divide it by this number to get your slope with the opposite sign. So this positive 2 over 3, even though you have a negative 2 and a positive 3. Okay, so anyways, to get a second line, basically we just need to write any random line with a different slope. Okay, so for example, and again, there's infinitely many solutions here. I can just write 5x minus, I don't know, 2y equals 17, just a random line here. This slope here of this line is, again, it's going to be 5 over 2. All right, so I just take the number in front of the x, divided by the number in front of the y, and then change the sign. Right? So if I took 5 divided by negative 2, that'd be negative 5 over 2, but then the slope of this line is 5 over 2. Right? So you can kind of backtrack and check this one. If I took negative 2 divided by 3, that's negative 2 over 3, but then I switch the sign to get the slope. That's basically what we do when we're solving for y. Right, so again, one solution is when you just have different slopes. All right, next up, no solution. All right, so I'm going to need this equation, negative 2x plus 3y equals 18. All right, so how do we get no solution? Well, we'll have the same slope, but a different y-intercept. All right, so when it comes to creating a line here, I can actually just copy these two terms here, negative 2x plus 3y. Because, if I was to figure out the slope here, the slope of this line is, just like I showed you before, is 2 over 3. Slope of this line is, since the numbers are the same, it's also 2 over 3. All I need to do here is change this number. I can go with just 1. So as long as this one is a different number. All right, on that side. That will create a line with the same slope, but a different y-intercept. So this could, as long as it's not 18, it can actually be negative 18 if you wanted. But once it's not positive 18, then you're going to have two lines with the same slope, but different y-intercepts. Now, the third possibility is when we have infinite solutions. Right, so again, just let me write up the first line that they give you in the question. Example. All right, so now this is where, to get the second line, basically we want the same line, but we just want to write it in a different way. Now, to do that, is hopefully you guys already know kind of ahead of time, you can just multiply both sides or multiply each one of these terms by the same number. Right, so for instance here, if I multiply through by 2, my second equation here is negative 4x plus 6y equals 36. So this is technically a different equation, but it's the same line, same graph, as long as you multiply through by the same number. All right. And just to show that that is true, use our good old friend Desmos to visually show you that that is true. So, so the first line that we were dealing with here, negative 2x plus 3y equals 18. X plus 3y equals 18. All right, so it's kind of off the grid there, but anyways, that's the line that's given in the example. And then if I graph the second line where I multiply 3 by 2, it should be the same as this line. So in other words, it's going to overlap this one. All right, so that's negative 4x plus 6y equals 36. Plus 6y equals. All right, so 30. It's 3 there. You guys ready for this? 36. You can see that now that line is blue, right? It overlaps. So if I toggle it off, it's red, toggle on. So it's the exact same line, just looks differently. And so that's how you create infinitely many solutions. All right, guys, so that is, so that's a lesson on properties of systems of linear equations.